Welcome to the session on straight line graphs, equation of a straight line. The objectives for this session are to find the equation of a line given the gradient and one point on the line, or find the equation of a line given 2 points on the line. The gradient of a straight line is its slope. It is calculated by dividing the vertical distance by the horizontal distance between 2 points on the line. So for example, if we have 2 points, x1, y1 and x2, y2, and the 2 points are joined by a straight line, then the difference in the y coordinates is y2 minus y1, and the difference in the x coordinates is x2 minus x1, and the gradient is y2 minus y1 over x2 minus x1. So change in y over change in x. Let's take a look at an example. Find the gradient of the line which joins the points minus 3, 8 and 3, 6. We can draw a sketch of this just to give us an idea of what is happening if we need some clarity. Therefore, m equals y2 minus y1 over x2 minus x1 as shown. Tidying up, this gives us that m is equal to minus 2 over 6, or minus a third. So the gradient m equals minus 1/3. Let's take a look at another example. Suppose the line joining 3, minus 7 to 8a has gradient minus 2. Work out the value of a. Now the gradient m equals y2 minus y1 over x2 minus x1 as shown. Tidying up gives us a plus 7 over 5. We know that this is equal to minus 2. Now solve for a. Multiplying out, a plus 7 over 5 equals minus 2 gives a plus 7 equals minus 10. And finally, rearranging gives a equals minus 17. The equation of a straight line can be written as y equals mx plus c, where m is the gradient and c is the y-intercept. Or it can be written as ax plus by plus c equals 0, where a, b and c are real numbers. We will now proceed to find the values of the gradient and y-intercept for the equations shown in example 3. Let's begin with example 3a. Now y equals minus 8x plus 5 is already in the form y equals mx plus c. So the gradient m equals minus 8. And the intercept c equals 5. We will now proceed to find the gradient and y-intercept for part 3b. Since 2x plus 8y minus 7 equals 0 is not in the form y equals mx plus c, we need to make y the subject of the equation first. So therefore, rearrange 2x plus 8y minus 7 equals 0 so that y is the subject of the equation. Hence, 8y equals minus 2x plus 7. And dividing by 8 gives y equals minus 1 over 4x plus 7 over 8. So the equation is now in the form y equals mx plus c. And we can now see that m equals minus 1 over 4 and the y-intercept c equals 7/8. Let's have a look at another example in which we rearrange equations into the form ax plus by plus c equals 0. We will proceed to solve example 4a. Now y equals 2x minus 5. Therefore, subtracting y from both sides gives us the equation in the form ax plus by plus c equals 0, where a equals 2, b equals -1, and c equals -5. Now let's solve example 4b. We have that y equals 3/8x minus 5. Therefore, subtracting y from both sides gives us the equation in the form ax plus by plus c equals 0, where a equals 3/8, b equals -1, and c equals -5. Let's now have a look at an example where we find intersection points. We will proceed to solve example 5. Now y equals 2x minus 3 meets the x-axis at y equals 0. So putting y equal to 0 in the equation gives 0 equals 2x minus 3 at the intersection point with the x-axis. Therefore, rearranging gives that x is equal to 3/2, which equals 1.5. We will now take a look at some theory. A straight line is defined by either one point on the line and the gradient, or two different points on the line. Suppose a straight line with gradient m passes through the point x1, y1. If xy is a general point on the line, then the gradient m is equal to the change in y, which is y minus y1, over the change in x, which is x minus x1. So let's take a look at an example to illustrate this theory. Suppose a straight line has gradient 7 and passes through the point 4 minus 1. Find the equation of this line. So let's solve this. In our question, we have one point on the line and the gradient. So for a general point xy on the line, we can say that m equals 7, which is the gradient, equals y minus -1 over x minus 4. Multiplying out by x minus 4 gives 7 times x minus 4 equals y plus 1. And then expanding the brackets gives 7x minus 28 equals y plus 1. And finally, rearranging and tidying up gives y equals 7x minus 29. Let's take a look at another example to illustrate this theory. Find the equation of the straight line passing through the points 2, 10 and -1, -8. So let's solve this. Now the gradient of the line m is equal to 10 minus -8 over 2 minus -1. This equals 18/3, which is 6. So m is equal to 6. If we suppose xy is any point on the line, then m equals 6 equals y minus 10 over x minus 2. Therefore, multiplying out gives the equation shown. And finally, tidying up gives us y equals 6 times x minus 2. Let's take a look at another example to illustrate this theory. The line y equals 5x plus 2 meets the y-axis at point A. find the equation of the line with gradient 4/5 which passes through point A. Write your solution in the form ax plus by plus c equals 0, where a, b and c are integers. We will tackle the solution to example 8a first. Now when x equals 0, we have y equals 2. Therefore, a equals 0, 2. The gradient of the second line is m equals 4/5. So if xy is a general point on the line, then m equals 4/5, which equals y minus 2 over x minus 0. Rearranging gives 4x equals 5y minus 10. Now let's solve part 8b. Write your solution to part A in the form ax plus by plus c equals 0, where a, b and c are integers. From part A, we have that 4x equals 5y minus 10. So rearranging gives 4x minus 5y plus 10 equals 0. Let's take a look at another example to illustrate this theory. Let A be the intersection point of lines y equals 2x plus 8 and x plus 4y plus 13 equals 0. If the point B has coordinates minus 3, 10, find the equation of the line passing through A and B. Write your solution in the form ax plus by plus c equals 0, where a, b and c are integers. We will tackle the solution to example 9a first. To find a, substitute y equals 2x plus 8 in x plus 4y plus 13 equals 0. So x plus 4 times 2x plus 8 plus 13 equals 0. Hence, 9x plus 45 equals 0. Rearranging gives 9x equals minus 45, and therefore x equals minus 5 once we've divided through by 9. Now substitute x equals minus 5 in y equals 2x plus 8, as shown. And tidying up gives us y equals minus 2. Therefore, a is equal to minus 5 minus 2. Now solve example 9b. Now from part A, we know that a equals minus 5 minus 2. And from the question specification, we have that b equals minus 3, 10. The gradient of the line passing through A and B is m equals minus 2 minus 10 over minus 5 minus minus 3, which equals minus 12 over minus 2, which is of course 6. And therefore m equals 6. So if xy is a general point on the line, then 6 equals y minus minus 2 over x minus minus 5. Tidying up gives us y plus 2 all over x plus 5. And therefore 6x plus 30 equals y plus 12. And tidying up some more gives 6x plus 18 equals y. So the equation of the line passing through A and B is 6x plus 18 equals y. Now let's solve example 9c, in which we are asked to express this equation in the form ax plus by plus c equals 0. So recall that the line was expressed as 6x plus 18 equals y. So let's rearrange this. If we subtract y from both sides, we obtain 6x minus y plus 18 equals 0. This brings us to the end of this session. If you have understood its contents, you should be able to find the equation of a line given the gradient and 1 point on the line, or find the equation of a line given 2 points on the line. Thank you very much for listening. If you would like to understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.